Last time we have started kinetics of a rigid body, okay? And if you remember, we have demonstrated together that in case of a rigid body, if I do sum of moment about any point P on the rigid body, I end up with the following relation. Sum of moment about P equals to minus y bar m apx plus x bar m apy plus ip alpha, where apx, apy are the coordinates of acceleration of point P, and y bar and x bar represents coordinates of center of mass relative to the frame of origin P. Okay? So the first particular case to consider is the one if we put P at the center of mass. And we said that if we put P at the center of mass, then the axis xy will be centered, the origin will be G. Okay? So if I put P here on G, this is my y-axis, this is my x-axis. In this case, coordinates of G with respect to this frame will be what? If I put P at G, what will be coordinates of G in this frame?
0, 0.
0, 0. Therefore, my equation will become sum of moment about G equals to Ig alpha. Why? Because x bar and y bar will be 0. Okay? So this is the general relation that I can use for any type of motion. Sum of moment about the center of mass is equal to Ig times alpha. Okay? This is always applicable, whatever is the type of motion. Now, we want to derive another expression for this theorem. So what we did is we considered that we want to express sum of moments about any point P function of Ig alpha and function of acceleration of G. This is why what we did is we went back to the previous formulation, okay? And we said that in this relation, we have sum of moments about P equals to minus y bar apx plus x bar apy plus ip alpha. And we said that we want to find another equation but involving Ig alpha, okay? If we want to involve Ig alpha, what should we do? What is the relation between Ip and Ig? Who can tell me? You know, from the parallel axis theorem, I can write that I, inertia about P, is equal to inertia about G plus what? Plus
mr square.
D
md
squared.
square, yes? D square is the distance between P and G, so it's mpg square. But pg is nothing than what? What is pg? How to calculate it? If I go back to my figure, okay? The distance between P and G is equal to radical x bar square plus xy square.
Y bar square.
Because the distance between P and G is this one. This is my distance of interest between P and G. I can calculate it as radical x bar square plus y bar square. So I can say that PG square can be replaced by x bar square plus y bar square. Okay? So in this case, if I go back to my relation, okay, I will replace IP alpha by Ig alpha plus m x bar square plus my bar square. Okay? And now, if I take y bar m into factor, I can see that I have mx bar that is repeated 2 times. So I can take mx bar into factor. If I take mx bar into factor, I have apy plus x bar alpha. And if I take y bar m into factor, I have minus apx plus y bar alpha. Yes? Did anyone ask a question? I cannot hear you. Can you type it, please? So look, now what we want to try is to involve AG in this equation. To do this, we want to find what is minus APX plus Y bar alpha and what is APY plus X bar alpha. To find this, we want to relate acceleration of P to acceleration of G in order to find the relation between the acceleration of these 2 points. Now, since P and G are 2 points of one rigid body, then we can relate their accelerations. Okay? So we can write that AP is AG plus alpha vectorial PG minus omega square PG, if you remember. Because if we have any 2 points on the same rigid body, we can relate their acceleration. So this is what we will do here. So AG is AP plus alpha vectorial R, which is PG, minus omega square PG. Now I will replace each term by its component. So AG is AGXI plus AGYJ. AP is APXI plus APYJ. Alpha is in the counterclockwise direction, so it's plus alpha K. Vectorial R. Vector R is vector PG, and vector PG can be decomposed into X bar I plus Y bar J minus omega square PG, so minus omega square X bar I plus Y bar J. Now, if I do the expansion, نعم منير.
we are not seeing what you are explaining.
Now or from before?
بس بعدنا
لا
على
no
السلايد من الأول.
بعد على الصفحة هذيك.
Okay, يلا I will check the problem, one second. Now,
Yes.
باين.
you want me to repeat something or it's fine?
مس بليز بس هيدي الريليشن تبع ماينس واي بار ام والاي بي واي من وين جبناها؟
Okay, I will, yeah. Look, my purpose is to express some of moment about P, function of acceleration of G and IG. I don't want to express it function of AP, okay? So I will go back to my previous relation. My previous relation is sum of moments about P is minus Y bar M APX plus X bar M APY plus IP alpha. Now I want to find a relation, not function of acceleration of P, but function of acceleration of G, and not function of IP, but function of IG. This is what I want to do. How to do this? First, to get rid of IP, I apply the parallel axis theorem. From parallel axis theorem, I can replace IP by what? By IG. I will do the parallel axis theorem. IG plus M times PG square. Okay? So, all I have to do is to find what is PG. If I go back to the previous figure, are you seeing the previous figure here?
Yes.
Okay.
Yes.
The distance between P and G can be calculated by radical X bar square plus Y bar square. Okay? So when I do PG square, it's X square plus Y bar square. So I can replace IP by IG plus M X bar square plus Y bar square. This is first. Okay? Second, if I go back to my expression here, I want to introduce AG. How to do this? I replace first IP by IG. So I have here, I have IG alpha plus M X bar square, okay, plus M Y bar square, okay? And I can see from previous expressions that I have a term into common. So here I have mx bar, and here I have mx bar times APY. So I will take mx bar as factor. If I take mx bar as factor, I obtain APY plus x bar alpha, okay? And because look, this term is multiplied by alpha here because it's IP times alpha. So when I multiply IG plus MPG squared by alpha, I will obtain here mx square alpha plus my square alpha. Okay? Now, taking into factor mx bar, I have that mx bar is common for mx bar square alpha and for mx bar APY. So taking mx bar into factor, I get mx bar times APY plus x bar alpha. And taking y bar m into factor, I obtain y bar m times minus APX plus y bar alpha. Okay? So all I did, I considered terms that have in common y bar m and x bar m, and I take them together. Okay? Is it clear how we obtain this equation?
Yes.
Okay.
Yes.
Now, what I want to do, I want to try to get rid of AP. So I want to relate AP to AG. To do this, P and G are 2 points of one rigid body. This is why I can relate their acceleration using the rule we have developed in previous chapter, which is AG equals to AP plus alpha vectorial R minus omega square. Now I will replace each vector by its expression. So AG has two components in x and y, AGX and AGY, and AP can be written as APXI plus APYJ. Alpha is always along the perpendicular to the plane of motion, which is along K. So it's alpha K vectorial R bar. R bar is vector PG, and vector PG, as you can see here, what are coordinates of vector PG?
X
X
bar
bar
Y
Y
bar.
bar.
Very good. So I can replace vector PG by x bar I plus y bar j. So, and minus omega square PG, so minus omega square x bar I plus y bar j. Now I obtained a vectorial relation. After doing the expansion, as usual, what do? I obtain two equations. One by comparing along I. So this equation is by comparison along I, and this equation is by comparison along j. By comparing along I, obtain AGX equals to APX minus y bar alpha minus x bar omega squared. And AGY equals to APY plus x bar alpha minus y bar omega squared. Okay? So I can say now, if you go back to the previous slide, what I want is, what is minus APX plus y bar alpha? So if I take minus APX plus y bar alpha, what do I get? Take them to the other side. I get minus x bar omega square minus 8gx.
Yeah.
So I can replace minus APX plus y bar alpha. I can replace it by minus 8gx minus x bar omega square. And I can replace APY plus x bar alpha by AGY plus y bar omega. Okay? So what I did now, if I replace back into my equation and I do the development, I will reduce my equation to sum of moment about any point P is minus y bar MAGX plus x bar MAGY plus IG alpha. Okay? Any question until here? Now, what is the physical interpretation of this relation? To understand it better, okay, it's very simple. Let's go back to this figure, okay? When I do sum of moments about P, this means that I am doing sum of forces of all, sum of moments of all forces acting on the rigid body about P. And you know well that always I can represent what is taking place on my rigid body by what is taking place on G. Why? Because in general, sum of forces on a body is equal to MAG. So I can reduce my system to one point G and I put a vector MAG at this point. This vector MAG can be decomposed into two components, MAGY and MAG. Okay? But also, in case of a rigid body, it's not enough to represent my system by one force. I need also a couple. What is the couple? When I reduce my system at G, the couple will be equal to sum of moments about G. Because you know, when you take a force from one point to the other, you should add what? To have equivalent system, you should add the moment about this point. And we know that sum of moment about G is what? Is IG alpha. So I can reduce any system of forces and couples to one vector force and one vector moment at point G. The vector force will be MAG, and it can be decomposed into two components, MAGX and MAGY. And the equivalent couple at G is equal to sum of moments of forces and couples about G and is equal to IG alpha. So now I reduced my system to vector MAG and to couple IG alpha. Now, if I want to find the moment about any other point in my figure, so if I want to find moment about P, okay, how can I do this? If I tell you I have one force and one couple at G, and I want to find the couple at P, what should you do? What should you do to find the couple at P?
R cross summation F.
Okay, so I will write sum of moments about P. Okay, sum moments about P equals to what? First, when I have a couple, the couple is a free vector. I can consider it about any point, yes or not? In statics, you remember? In statics, if you do sum of moments about P and you have a couple, you don't take it into consideration. Yes or not? So first I should consider the couple. The couple is IG times alpha. Plus, what also? I should consider the moment of my force vector about P. And my resultant force vector is equal to what? Is equal to MAG. So the moment of MAG about P is equal to the moment of the resultant force about P. If I want to find the moment of vector MAG about P, so plus moment of vector MAG about P. How to find moment of vector MAG about P from this figure? So it's equal to IG alpha plus, look at your figure. If I choose the counterclockwise as positive, okay, I have that AGX has a positive, AGY has a positive moment, but AGX has a negative moment. So for AGY, it's plus MAGY times X bar, okay, plus the moment of MAGX, and because it's in the clockwise direction, so it's minus, so minus MAGX times Y bar. So what can I deduce? I obtained the same relation I developed now. So physically, this relation will tell me that sum of moments about any point P is equal to IG alpha plus moment of vector MAG about P. Okay? Is this clear? Do you want me to repeat anything?
بس دكتور سؤال
Yeah.
مش هو the الفورس is passing through the axis of rotation
Yeah.
ساعتها المومنت تبعه بتكون زيرو؟
مظبوط بس نحن أي forces are passing by the axis of rotation؟ أنت عم تحكي about G أنجلو أو about P؟
G.
Okay مظبوط ما أنت when you take about G you only have sum of moment about G equals IG alpha. You don't consider moment of MAG about GY because MAG is passing by G. So MAG cannot produce a moment about G. This is why sum of moment about G is restricted to only IG alpha. However, when you do sum of moment
Okay.
about P, when you do sum of moment about P is not only IG alpha, but you should add also the moment of vector MAG about P. Okay?
Okay. Okay.
Any other?
دكتورة
Yes, Munir.
P is uh, uh, P is taken arbitrary is an arbitrary point taken as origin ولا
Yeah, and
it should be
any
specific
point you
point?
want, any point on your body.
We make it as an origin ونشتغل على الأساس.
Yes. You can take it as any
بس
point on the body.
بس
Yes.
بس من وين بجيب AGY و AGX بعمل sum of forces.
Yes. بعمل sum of forces equal MA. Very good. بجيب AGX و AGY.
Okay.
Any other question? Okay, so let us continue. So now we have developed a general relation to find sum of moment about any point. Now we will start to consider particular case. Okay? The first particular case is what? Is translation. In case of translation, angular velocity omega is 0 and angular acceleration alpha is 0. So we have only, if we do sum of moments about G, it will give us what? 0. Because what is sum of moment about G? Sum of moment about G is IG times alpha. And because in translation alpha is 0, then sum of moment about G will be 0. But please pay attention. In translation, only sum of moment about G is 0, not about any point. Because if I consider any other point than G, if I consider point P, for example, if I consider point P here, then I cannot say that sum of moment about P is 0. Why? What is sum of moment about P in case of translation?
MAGX times
mg squared.
Very good.
G
So in
alpha.
case of translation, if I choose a point different than G, then I will say that sum of moment about the point is equal to moment of vector MAG about this point. But I don't have alpha, so it's only moment of vector MAG about this point. Okay? And the two additional equations for translation are sum of x equals MAGX and sum of y equals MAGY. Okay? So, any question until here? So let's go now to, so as we are saying, in rectilinear translation, if I want to find sum of moment about any point on my body, I can say that sum of forces and sum of moment of forces and sum of couple about A is equal to what? Is equal to moment of vector MAG about A. So if I look in this figure, I can say that sum of moment of couples and forces about A is equal to MAG times distance D. Okay? Now, if I consider curvilinear translation, do you know what do I mean by curvilinear translation?
يعني the body is moving at a curvilinear trajectory without doing rotation.
Yes. So curvilinear translation means that if I follow the center of mass of a body, it will not move on a straight line, it will move on a curve. Okay? But it's moving on this curve without rotating. So it's moving on a curved path without doing rotation with respect to itself. Okay, so alpha and omega are still 0, but when I consider point G, for acceleration of G, I defined a G normal and a G tangential because G is going through a curved path. Then in this case, what will be my equations? Instead of sum of x, sum of y, I will have sum of f normal equals mag normal, and sum of f tangential equals to mag. Here you should add m times mag equals mag tangential. And of course, sum of moment about G is 0. But if I take any other point than G, if I take, for example, point B in this figure, if you look at this figure, do you see it? The figure here at the bottom. Okay. If I want to do sum of moments about B, I should consider moment of vector mag about B. And here, because I'm working in normal tangential coordinates, I will divide ag into mag normal and mag tangential. So you can see in this figure that ag tangential is producing a moment in the counterclockwise, which I consider as positive. So it's plus mag tangential times the distance between point B and the line of action of AG tangential. So if I look here, this is the line of action of AG tangential, and I should consider the following perpendicular distance for the moment. This distance is equal to E. So I have E times MAG tangential. Now, for AG normal, this is the line of action of AG normal. It's producing a clockwise moment about B. This is why I have a minus, and I multiply by the distance from B to the line of action of MAG normal. This distance is H. So I get that sum of moments about B is equal to E times MAG tangential minus H times MAG normal. Okay? Now, let us consider an example to see how we solve in 2D motion. Okay, so the car has a mass of 2 megagram and a center of mass at G. Determine the car's acceleration if the driving wheels in the back are always slipping, whereas the front wheel freely rotates. Neglect the mass of the wheels. The coefficient of kinetic friction between the wheels and the rod is mu k equal to 0.25. Now, please pay attention for a thing. When they say the mass of the wheels is negligible, and when I have wheels that are freely rotating and they have negligible mass, then I don't have friction on the wheels. While for the back wheels, they are slipping. Because the back wheels are slipping, then they are subjected to the kinetic friction. So if I want to draw the free body diagram of forces acting on this car, I have the friction force at the front wheel, at the back wheels, sorry, okay? For the front wheels, no friction because they freely rotate and they have negligible mass. So I have only the friction force at B, and I have as additional forces the normal reaction at A and the normal reaction at B. Okay? And here I want to solve for the acceleration of my car. I want to find what is the acceleration of my car. So what are my unknowns here? My unknowns are an A, and B, and the acceleration of my car, okay, and AG. So I have 3 unknowns. I need 3 equations. What are the 3 equations to use? What are my 3 equations? First one, sum of
Summation
x.
of MX.
Yes, very good. Sum of x equals to MAG x, okay? And sum of y.
MAGY.
Very good. Sum of y. بس شو هي AGY here? What is AGY
Uh,
here?
0.
زيرو.
زيرو لانه الموشن بس على
Yeah.
اكس.
Okay. And what is the third relation?
The sum of moments.
أي point بدكم ناخد هون؟ للsum of
G
moment.
أحسن شيء.
فينا ناخد G. إذا أخذنا G يكون sum of moment about G شو؟ Zero.
زيرو.
Because
Zero.
it's translation. Okay? Because it's translation. So sum of moment about G is zero. Now, who can tell me the friction force is to the left or to the right? How can I know? How can I know if my
احنا we can
Yeah.
assume it anything وبعدين
Look,
we know how its direction.
no, I should read well the given. What did they say? They say the driving
if
the
it's
driving
flipping
wheel.
يعني راح تروح لورا يعني
Yes.
يعني
لا.
الفريكشن لقدام.
مظبوط. قالوا the driving wheels when it's a driving force then it is in the direction of motion. يعني the friction is towards the left. Okay? Now, once I put my different unknowns and I put my equations, I can solve for my system. So let us write the three equations and solve for the system. So first, this is my free body diagram. If I write sum of x equals MAGX, if I consider the positive direction to the right, then I have minus mu kn equals to minus MAG. Okay? Or I can, if you want, I can take the positive direction to the left. If I take my positive direction to the left, my equation will be plus 0.25 NB equals to MAG. Okay? So this is my first relation. My second relation is sum of y equals to 0. So I will get NA. So I have NA plus NB minus the weight equals to 0. Now, for sum of moment, I can do I can take the point I want. If I take sum of moment about G, what will be my equation? I will choose a positive direction. If I choose the counterclockwise as positive, for example, okay? So I have, if I take NA is rotating in the clockwise direction, so it's a negative moment. So minus NA times the distance, which distance I take? This one, which is 1.25 meters. Now for NB is rotating in the positive direction, so it's plus NB times this distance, and this distance is 0.75 meters. Don't forget the moment of friction. This is my friction force. So I should do the projection from G to the line of action of the friction, which is the horizontal line. If I do the projection, this distance is equal to 0.3 meters. And if I do the right-hand rule, FB is rotating in the clockwise direction, which is the negative direction.
So minus.
So it's minus mu kn times 0.3 equals to 0. I obtain three equations with three unknowns. I can solve for my three unknowns. Angela, you are asking a question?
لا بس قلت minus.
Okay. Okay. Now, if I want to choose another point, if I want, for example, it would be good to choose which point to do sum of moments about other than G. Look at the figure. I have a point that is very easy, B. Why B? Because B, if I take B and FB will not have any moment. So if I do sum of moments about B, okay, here they consider sum of moments about A, but me, I will do for you about B because it's easier. If I want to do sum of moments about B, what will be my relation? So if I do sum of moments about B, it is not equal anymore to 0. It's equal to what? It's equal to moment of vector MAG about B. Okay, so here, if I look at my figure, this is vector MAG. What is the moment of MAG about B? It's a counterclockwise moment. So I have plus MAG times which distance? What is the distance from G to B?
0.74.
No, pay attention. Look, always,
0.3.
yes, 0.3. You should always project the perpendicular distance. This is MAG direction, and this is the projection from B on the line of action of MAG. What is the distance? 0.3. So I multiply MAG by 0.3 equals to sum of moment about B. What is sum of moment about B? I don't have the moment for NB and FB. I have the moment of the weight. The moment of the weight is in the counterclockwise direction, so it's positive. So I have plus 200 times 81, which is the weight, times the distance. Which distance I take for the weight?
Now I take 0.7.
0.7.
Now I take this
Five.
distance, 0.75. So times 0.75 plus, now for NA, the moment of NA about B is positive or negative? NA about B is doing a clockwise
Negative.
moment. So it's negative.
Negative, yeah.
So minus the moment of NA, which is NA times which distance? From A, now I take the distance from A to B, which is 2 meters times 2. So in this way, I can obtain another equation. So I can do, instead of sum